The question which we are discussing here, we have taken from complex numbers. Here question is, find real values of theta for which 3 plus 2i sin theta upon 1 minus 2i sin theta is purely real. Purely real means if z is complex number a plus ib, this is purely real if imaginary part b is equal to 0. Imaginary part will be 0, then simply z is equal to a, which is a real part of the complex number, which is a real number. So here we have to show, after expansion, after simplification, we will show that imaginary part of this expression is 0. Okay. So let us see the solution here. Here given expression is 3 plus 2i sin theta upon 1 minus 2i sin theta. For simplification of this expression, we will multiply numerator and denominator by conjugate of the denominator. How we will get conjugate of this denominator? By simply changing the sign of imaginary part. If this is minus 2i sin theta, if you take plus 2i sin theta, this will be conjugate of the denominator. So conjugate of 1 minus 2i sin theta is 1 plus 2i sin theta. And we will multiply here numerator and denominator by this conjugate 1 plus 2i sin theta. So multiplying with 1 plus 2i sin theta, and in denominator also 1 plus 2i sin theta, correct? In denominator, this is in the form of a minus b into a plus b, which is equal to a square minus b square, means 1 square minus 2i sin theta whole square. And here these two expressions will be multiplied with each other. So first we will multiply 1 plus 2i sin theta with 3. Then again we will multiply this 1 plus 2i sin theta with 2i sin theta. So when we will multiply 1 plus 2i sin theta with 3, 3 into 1 is 3, plus 3 into 2i sin theta is 6i sin theta. Now multiplying with 2i sin theta into 1 is 2i sin theta, and plus 2i sin theta into 2i sin theta, that is 2i sin theta whole square. 2i sin theta whole square, correct? Simplify it further. 1 square is 1, and minus 2 square is 4 into I square is minus 1 into sin square theta. And in numerator, this is 3, 6i sin theta plus 2i sin theta, this is 8i sin theta, and plus 2 square is 4 into I square is minus 1, and this is sin square theta. Okay. In denominator, minus 4 into minus 1 is plus 4. So denominator will be 1 plus 4 sin square theta, and in numerator this will become minus 4 sin square theta. So 3 minus 4 sin square theta, and this is real part, and imaginary part I into 8 sin theta, correct? If you write 1 plus sin square theta for the expression 3 minus 4 sin square theta and I 8 sin theta separately, then we will get This is 3 minus 4 sine square theta by 1 plus 4 sine square theta plus I into 8 sine theta divided by 1 plus 4 sine square theta. Here given that expression is purely real. So this is purely real if imaginary part is 0. We know, okay? If b is 0 here, means imaginary part is 0. So if this much is 0, so 8 I sine theta upon 1 plus 4 sine square theta is 0. This implies that this numerator is 0. This implies 8 sine theta is 0. And this implies that sine theta is 0. And sine theta is 0 when theta is n pi. This implies that theta is equal to n pi, where n is any integer, where n belongs to set of integers z. So here we have to find real values of theta. So real values of theta is here this much. Theta is equal to n pi, where n belongs to z. N is an integer, correct? Hope you have understood it. So this is the answer. This is the required value of theta, n pi, which has been asked in this question. Find real values of theta for which this expression is purely real. So when this expression is purely real, after simplification, we are getting the values of theta, which is equal to n pi. Hope you have understood it. Very interesting. Okay. So please share this video with your friends also, and hope you have subscribed this channel. If not, please get it subscribed. I need your cooperation, and remain in touch with these videos. We will see some more important questions. Wish you all the best.